So in this video, we're just going to continue talking about rules of differentiation. And we have a lot of information here about what a derivative really is. So the original function we call our position function. Usually it describes maybe our height or where we're located on the graph. If we take the first derivative of that, sorry, that's a typo. If we take the first derivative, that's going to give us the velocity of our function, which tells us how its position is changing. If we take the derivative again, we are left with acceleration, which tells us how our velocity is changing. So a derivative always describes how the original is changing. So we can think of the acceleration, which is the second derivative, really as the first derivative of velocity. So just a couple things. Velocity is both speed plus direction. Speed cannot be negative. So speed is the absolute value of velocity. Our speed is increasing if velocity and acceleration have the same sign. That is if they're working together. So if they're both negative, there are two forces working together in the negative direction, so our speed is increasing. If, however, they have different signs, meaning they're working against each other, then my speed is decreasing. So that might be, maybe I'm moving in the positive direction, but my force is pushing me backwards. Our position function is just a regular function we've seen since middle school. This is always our initial height, and this is our initial velocity. We use 32 feet per second, or 9.8 meters per second for, per second squared, for acceleration due to gravity. So let's go ahead, we're going to take what we learned in the last video, and now we're going to write the entire equation of the tangent line. So remember, a tangent line is linear. So we have a function, and at the point 5, -3, this is a cubic function, so it's going to have lots of curves in it. And we want to find the equation of the tangent line at that point. So we need finding the equation of that blue line. Because a tangent line is straight, we need to use the formula for a linear function. So we're going to use point-slope form because we know the point of tangency, and we can use the derivative to find the slope at that point. And I'm actually going to change this to the 0.13. I think it says 1 in your notes. But anyway, so if I find the derivative, I take the 5 down and I multiply it. So those are going to cancel, and I'm left with 2x, and my new exponent is going to be a 4. Now my 4 comes down, and I'm going to have 4x to the third. My 2 comes down and multiplies by the 3, and it's now to the first power, and the derivative of a constant is 0. Because I need the slope of the tangent line at this point, I'm going to take my x value, which is 1, and I'm going to plug it in. So if I plug that in, I'll have 2 plus 4 plus 6, which gives me a slope of 12. So I know the slope and I know the point. Now I'm just filling in the pieces. So I'll say y minus y1 equals my slope, which is 12, x minus x1. And this gives me the equation for the tangent line at this point. And it's actually, since I changed it, it's going to be at 1, -3. So I actually found the equation of that one. So for our last example here, we have a word problem. We have a diver diving in the water. So we're driving off this platform. Here we have our position function, which is our height. And the question says, when does the diver hit the water? So when is asking me for a time. I want to know when the diver hits the water. That's going to be a position, and it's going to be position 0. Right there is going to have a height of 0. So I use my position function, and I want to know when that height is 0. So we're going to factor our function. So let's factor out a -16. I'm left with t squared minus t minus 2. And if I continue to factor, I'll get t minus 2 and t plus 1. Setting those factors equal to 0, I see that t could equal 2, or t could equal -1. Now, in a quadratic function, obviously, we can't go back in time, so the positive 2 is when this diver hits the water. The negative one represents if this function were to continue on the other side, that's where it would hit. So we really don't need that in this problem. So it's going to be after 2 seconds. The question now says, what is the diver's velocity at impact? So when he hits the ground, or the water, after 2 seconds, what is his velocity? And the velocity is found by finding the first derivative. So s prime of t will give me the velocity. So again, I use the power rule, so I'll get negative 32t. Here I'll just get plus 16, and the derivative of 32 is 0. So this will give me the velocity at any point, and they want to know specifically when he hits the water. So that specifically happens when t equals 2. So I need to find the velocity when time is 2. And I'm just going to plug this in. I'll get negative 64 plus 16, or negative 48. Okay, so his velocity, remember, which is both speed plus direction, is negative 48. And in this case, we were measuring in feet per second. It's negative because the diver is going down. So the distance here, the height, is decreasing. So that's why that's negative.